So this is A. Okay, the triple integral using the spherical coordinate. The power, okay, the question 1, the power emitted by a certain antenna, it has a power density per unit volume of, okay, the P here is a power, okay, emitted by a certain antenna, okay, where already in the spherical coordinate form, we have the rho, phi, theta. The power is actually the P naught, where the P naught is a constant here, with the unit in watts. So divided, okay, by the rho squared sin power 4 phi cos squared theta. Okay, this is a power. Okay, and the total power P satisfies the triple integral P. Okay, this one. P rho phi theta is given by P naught over rho squared sin phi power 4 cos k squared theta dt. So we would like to solve, okay, find what is the power, okay, total power within a sphere of radius 10 meters. So they are give you the power emitted by an antenna is given by the triple integral, okay, P rho, okay, phi theta, and the P rho phi theta is actually this one. So we plug in the function of P as a P naught over rho squared sin P sin over 4 phi cos squared theta dt, and we solve it here because it's within a sphere of radius 10 meter. So this is a solid is in a of sphere. So we are going to solve it using spherical coordinates. Solution exactly triple integral. Okay, the function P is given by top here. Plug in the P naught over rho squared sin power 4 phi cos squared theta. Okay, and dv in spherical coordinate, you have to change it. dv is actually the rho squared sin phi d rho d phi d theta. Where the P naught is a constant, okay, constant, so you can factor out the P naught, so that's why you see the answer is in terms of the P naught. P naught is actually the initial power, so P naught is a constant. Then we need the limit for rho, phi, and theta. Okay, for sphere of radius 10 meter, so the rho will be 0 to 10, because rho is actually start from 0 up to the radius of the sphere, okay, and in this case is 10 meter, so the rho is actually 0 to 10. Rho from 0 to 10. Phi is actually, you have your this is the sphere. As I said, okay. Phi is actually we measured, okay. from the top, okay, you turn it this way, top surface until bottom surface. So it's half cycle. That's why phi is 0 to pi. 0 to pi. Okay, theta is actually, okay, or theta, you can get the projections, okay. The projection of the sphere is, okay, on 2D. So when you plot the 3D graph, we always mix positive x this direction, x, then this is y, x, y, z. Then in 2D, this is x, here, 1. Theta is actually measured here. So this is theta. So theta from 0 to 2 pi. So for a sphere, phi is 0 to pi. Hemisphere, phi is 0 to pi over 2. If cone depend on the cone equation, so you're solving the cone equation, then you know what is the phi there. So in this case, for sphere, phi is 0 to pi. Theta is like your polar coordinate. So theta will be measured, will be on 2 dimensions, or if you have a orange, you try to rotate it horizontally. Rotate it horizontally in this way. Let's say here you rotate. So it's 1 cycle, theta from 0 to 2 pi. Okay, after that, you just integrate it. So anyone having problem to determine the rho, phi, and theta or not? You can factor out the p naught, okay, it's a constant. So is rho squared and rho squared here. Just cancel it. 0 to 2 pi, 0 to pi, this is 0 to 10. So sin power 4, the power 1 total is sin power 5 phi, cos squared theta. Cos squared theta, the rho, the phi, the theta. Then first of all, integrate respect to rho, where the phi and theta are constant. These two are constant. So integrate a constant respect to rho, you have the constant time rho. So the p naught, 0 to 2 pi. This is 0 to pi. Okay, and integrate a constant sin power 5 phi. Cos squared theta is constant. So integrate constant respect to phi, you have constant time phi. Check out the constant here, where the phi is from 0 to 10. Then the left, integrate respect to phi and integrate respect to theta. So plug in upper limit of the phi, deduct the lower limit. So we have here 10. Factor out 10. Because it's constant here. Plug in here, you have 10. So 10 p naught, 0 to 2 pi, integrate 0 to pi, sin power 5 phi, cos squared theta, phi, theta. And then now you have to integrate respect to phi. So here how to integrate for sin power 5 phi respect to phi, where the theta is constant. Okay, if you don't know how to integrate, you may use your calculator to integrate it. Okay, let's say here you have difficulty to integrate here sin power 5 phi. Because you need some manipulation and it's quite long also. So you may use your scientific calculator to get the result. if you do manually, quite long, let's say you use your scientific calculator. Okay, when you integrate respect to phi, cos squared theta is constant. But for sin power 5p, you need some manipulation before you can integrate it. So you can, and since a limit is constant 0 to pi, you may directly use the scientific calculator to integrate one sin, bracket, sin. Make sure you in radian mode, sin x. See as sin power 5 0 to 5. Now this one is constant, constant, so that's why we just integrate sin power 5 phi dt. Of course, in calculator you have to put up x, 5 to 6. You get the answer is 16. Okay, this one the answer is 16 over 15. This one and you get this result is 16 over 15. 16 over 15. Left it 0 to 2 pi cos squared theta d theta. That means just now I integrate this one where this is constant. This is constant. So to cos squared theta you limit to the d theta. So we just integrate in what we do. Separate this one you factor out. Cos squared theta. You factor out near to d theta. You just integrate sin power 5 phi using calculator. You get the answer is 16 over 15. Lastly, this one, cos squared theta. You can also use a calculator to directly integrate it. If you don't want to change it, become half of 1 plus cos 2 theta. But this one to change it quite several steps to change it. So we use the calculator to see whether you can get so 16 over 15. And then this one, again, the cos squared theta. So the cos x, I put bracket and then square it. To get this part, the answer is pi. This one, the calculator give the answer here is pi. So this one is simplify. 32 over 3 p naught pi. You can get 32 pi p naught over 3. This part is pi. So any questions here? Here I just directly using calculator. If not, sin power 5p, sin power 5p, you need several steps to convert it before you can integrate it. Any questions here?
No.
No. The second one. Question 2 is to find the volume of the solid bounded below by cone and above by scale x squared plus y squared plus z squared equal to 4z. Okay, because notice this field equation, right hand side here is 4z. Normally, okay, we have equal to r, mean the r squared, where the r is the radius of the sphere. So you look at the sphere equation, x squared plus y squared plus z squared equal 4z. I think similar with the assignment question also. Because if in this case you need to do completing the square. Yeah, z squared minus 4z equal 0. Then we will have x squared plus y squared plus z squared minus 4z. You need to do completing the square. You have z minus 2 squared. So you square back z squared, correct? Huh? Negative 2 times negative 2 times z, so negative 4z plus 4. Okay, when expand this one, and expand back this, you actually get z squared minus 4z plus 4. So left side extra 4, right side you need to add up 4. So they are balanced, left side, right side. So plus 4 plus 4. So you get back here. So that's why this one. So now you get the right hand side 4. 4 is actually 2 squared. So mean the radius of the sphere is 2 units. And you have a sphere, but the center of the sphere, because z here becomes z minus 2, means sphere will be centered at the center of the sphere, x at 0, y at 0, but z equal to 2. With radius 2 units. So this sphere no longer centered like this one. Huh? Normally, the sphere centered at origin, x0, y0, z0. But this case, the center of the sphere is moved up at x still 0, y still 0, but z move up to 2. Move up to 2. So we will have the sphere some sort like and drawing not yet. So this is the sphere which is centered at x is 0, y is 0, but z equal to 2. See, when we draw, x is here, y, z here. Center of the sphere, x here 0, y here 0, but z move up to 2 units. So your sphere is on the positive z, positive z. compared to normally your sphere, okay, you have the actually positive z, negative z, but this one z are positive. So find the volume of solid bounded below by cone. Okay, this is the same cone equation that I have learned, okay, last night. And then, okay, above by sphere, that's why you have your ice cream cone. Okay, now will be the same thing. Okay. So it's a blue, okay, color here. You have the cone z equal to square root x squared plus y squared. So below is a cone, top is a sphere. So it's like the ice cream cone. But compared to last night, okay, your sphere is actually at maximum is, let's say, 2 units. Bottom you still got, okay, bottom you still have a lower hemisphere. But here your lower hemisphere also at the z positive. Okay, so the solid that the volume of the solid that we're going to find is the blue color solid. And that's what you have learned yesterday. To get the phi is actually from the positive z until the surface of the phi. Okay, if you can measure, okay, this will be the phi. Theta is actually you rotate horizontally, or you press the scale, okay, or the cone on xy plane. So you have a 2D, is a full circle. So your theta is 0 to 2 pi. And to get the phi, because the cone not necessary, okay, this equation. This is the simplest cone equation where the coefficient for x squared and y squared are same. So in this case, the projection of the cross-sectional area of the cone is a circle. Okay, if their coefficients, okay, it may not necessarily one x squared, one y squared, it may other key coefficient. So if there are other coefficient, the phi, yesterday we found this one, the phi is pi over 4. If you have different coefficient, the phi may be not pi over 4. To get the phi, exactly, you just solve this cone equation. To solve the cone equation, you square both hand side. You have the z squared equal to x squared plus y squared. So this is double cone. Upper cone is only upper part, double cone at the bottom we still have inverted upper cone there. Okay, and then you plug in, as you know, okay, for spherical coordinate, z is actually rho cos phi. So you square it, so rho squared cos squared. Okay, x is actually rho sin phi cos theta. So x squared. So this one squared, squared, squared. Okay, y is actually rho squared. Y squared. Y is actually rho sin phi sin theta. Okay, and then y squared. So this one squared, squared. Okay, you notice you have here rho squared sin phi, rho squared sin this one is sin squared. In for spherical coordinate, okay, spherical coordinate. Okay, and I think I'm not sure whether in the test the formula is given, but never mind, you think you can refer the open book, right? Open book, the z is rho cos phi, x is rho sin phi, y is rho x is rho sin phi cos theta, y is rho sin phi sin theta, and then you square it. Okay, so now we factor out rho squared sin squared phi, rho squared sin squared phi cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta is 1. So you get this is rho squared sin squared phi. So this one is actually rho squared cos squared phi. It's the same. Then you cancel the rho squared at both hand side. Left, right, you cancel. Now you have 1 equal to your sin squared phi divide 1 equal to your sin squared phi divide the cos squared phi. So mean you have a tangent squared phi equal to 1. So tangent phi is 1. Taking square root 1, 1. Taking the arctan, so arctan 1, you have phi is 5 over 4. That's why if the cone equation is given by z equals square root x squared plus y squared, phi is pi over 4. So anyone having questions on finding the phi here? So phi is from 0 to pi over 4. Theta 0 to 2 pi. Okay, the rho. Later on, so from here, you know, so phi is actually from 0 up to pi over 4. Okay, theta, because the projection is a circle, so theta is actually full circle, so theta from 0 up to 2 pi. Because on the xy plane you get a full circle, so the theta 0 to 2 pi. So now we left here how to get this one. From x squared plus y squared plus, we use back the original equations here. So x squared plus y squared plus z squared is actually rho squared. Okay, z is actually rho cos phi. Z is rho cos phi. So you cancel. Rho is actually 4 cos phi. So okay, your rho is actually from 0 until 4 cos phi. So compared to yesterday notes. Okay, compared to last night, last night, okay, the same cone, that's why p 0 to pi over 4, theta 0 to pi over, theta 0 to 2 pi. Still, x squared plus y squared plus z squared equal to 16. So rho is 4. So rho from 0 to 4. Because this one, okay, here, your sphere like this one. So your rho is here. This is rho. Okay, now this one. Because okay, your sphere is actually shifted up 2 units, so your phi is actually your rho from here touch, okay, this one from origin, which is rho 0 touch, okay, touch the sphere equation x squared plus y squared plus z squared equal 4z. So solving the sphere equation now, you get the rho is actually 4 cos phi. Rho is actually 4 cos phi. So the difference, okay, so now your volume for this ice cream cone, okay, theta 0 to 2 pi, still same, okay, as last night, P 0 to pi over 4, rho 0 to 4 cos t. Okay, and then dV, dV is actually given by rho squared sin phi d rho d phi d theta. So this is a dV. This part, this is dV in spherical coordinate. It's rho squared sin phi d rho d phi d theta. Okay, then you just need to integrate it. So integrate respect to rho, where the sin phi is constant, so you get rho cubed over 3. Over 3 I factor out as 1/3. So you get rho power 3 over 3 factor out as 1/3, where the rho from 0 to 4 cos phi. That's sin phi d phi d theta. Then plug in the upper limit of rho. So 4 power 3 you have 64 cos power 3 phi sin phi d phi d theta. So you can factor out 64, and then okay, you may use calculator or you want to integrate manually. Here you have a cos phi, this is sin phi d phi d theta. Okay, you may use calculator. When you click cos, you can use calculator or you can use substitution technique to integrate. This one you should get 64 over 3, 0 to 2 pi. Integrate cos power 3 phi sin phi. You should have negative cos power 4 phi divided by 4, 0 to pi over 4 d theta, where exactly we obtain using substitution technique. Replace u equal to cos. Replace u equal to cos phi, and you notice sin phi d phi is actually you have a like du d phi you get is actually negative. Du d phi is negative sin phi, so du is negative sin phi d phi. So you notice that sin phi d phi later on you replace by negative du. So it means sin phi d phi you replace by negative du. That's why the integral of cos power 3 phi sin phi d phi, this will be u, cos phi is u, so u power 3, sin phi d phi is our negative du. So I integrate u power 3, you get u power 4, here we have negative divided by 4. Substitute back u is actually cos. So that's why you get negative cos power 4 phi divided by 4 here. Or you may use calculator to integrate it. And you get this is 64 over 3. This is 0 to 2 pi. Okay, negative and 1 over 4 can be simplified. 1, 16, so that's negative 16. And then replace here. So you have the cos pi over 4 power 4. Here I factor out negative, so minus cos power 4 0 d theta. Okay, cos pi over 4, we have actually sec 2 over 2, and then power 4. Cos 0 is 1, so 1 power 4 is 1. Simplify this one. Okay, sec 2 0 to 2 pi. Sec 2 power 4 is actually you have 2 times 2, 4. 4 means 4 divided by 2 minus 1 is theta. So this one, this is 1. So the negative is 16 over 3. Integrate 0 to 2 pi theta. In the outer integral, you will get negative theta check. So negative, let me check here. Okay, the volume should be positive. This one is 2 pi. Check it, any mistake there. So, the mistake here, 2 power 4. Okay, sec 2 power 4 is actually 2 times 2 is 4. And then denominator here 2 power 4, 16. This one. So this one, one fourth minus 1. Negative 3 over 4 d theta. So 3 and 3 here. So just left 0 to 2 pi theta. And the answer given. Check it. The answer is 8 pi. Okay. Do you notice where's a mistake? Go through one more round. Integrate rho squared, you have rho cubed over 3. Plug in the limit of your rho 0 to 4 cos phi. So 64. Okay, we got 64 cos power 3 phi sin phi d phi d theta, and then okay, integrate. So factor out 64, you have 64 over 3, and then integrate cos power 3 phi sin phi d phi. You will get negative cos power 4 phi, negative cos power 4 phi over 4. Okay, and then okay, 4 and this 64 we simplify, we get negative 16 over 3, negative 16 over 3, and then later on we plug in the phi exactly from 0 to pi over 4. So cos k power 4 pi over 4, cos pi over 4 is 2 over 2, and then cos 0 is 1, so 1 power 4 is 1. Okay, and then 2 power 4 is actually 2 power 4 exactly, we have 2, 2, 2, 2, so this is 2 times 2, 4, 2 power 4 is 16, so we have 1 over 4, okay, 1 over 4. I think the answer is correct, and the answer given is wrong.
Ni sampai saya dapat sama.
2 pi.
8 pi.
8 pi.
Miss ada 4 pi kat luar tu. Aku darab dengan 2, aku dapat 8 pi.
This one, 1 over 4 minus 1 is negative 3 over 4.
Miss ada dapat 4 kat luar.
4. Yes, thank you. This is not cancelled. Thank you. This is 4. So 4 times 2 pi, 8 pi. Yes. Okay, thank you. So the answer is correct, 8 pi. Because simplify here, 4 times 4. Negative, negative, positive, so 4. And then, okay, this one you simplify here, 4. Lastly, the integrate 1 d theta is 2 pi, so answer is 2 pi. So this one using manual. If we use calculator, I think much faster. Let's see. Cos k, let's say we put this one. Cos x over 3, and then sin this power 3, this one sin zero to pi over 4. Okay, if we use K calculator to integrate this one, this part, the answer you have a 3 over 16. So 3 over 16 you multiply in this part using calculator, you straight away get 3 over 16. And from here, if you use calculator straight away, you get 64 over 3, and then 3 over 16, and then lastly integrate 0 to 2 pi d theta. Okay, this part you get 2 pi. This is 3 over 16. So this is 4. And then so 4 times 2 pi, also you get 8 pi. It will be much faster rather than you the substitution technique, plug in, and then just now simplify and find the square root also. This up to 2 power 4, and then we simplify careless mistake. So if we use calculator, I think much faster. from this integral, directly you get 3 over 16. So you multiply times with 64, divide 3, you get 4. The last integral 0 to 2 pi d theta, you get 2 pi. That's why 4 times 2 pi, the answer is 8 pi. So that is a question 2. Okay, and then question 3. Use triple integral to find the volume of the solid remain if a cube hole of length 2 units is filled out through the center of a sphere x squared plus y squared plus z squared equal to 9. Okay, exactly you need to find the volume of the sphere using triple integral, and then to find volume of they want to use a triple integral, otherwise you can just use volume of the sphere. Okay, you can get then deduct with the volume of the cube 2 units, 2 times 2 times 2, so it's 8. Then to check, actually you have a using geometric formula, volume of a sphere is actually 4 pi r cube over 3. So this one, the radius of the sphere is actually 3. So we got 3 power 3 divided by 3. This one becomes 2. So 9 times 4, 36 pi. So using geometric, volume of a sphere is 4 pi r cube over 3. So we get 36 pi. Okay, and then deduct, because from a sphere we drill out a cube of length 2 units. 2 units. So cube 2 times 2 times 2. The width times the length times the width, height. 2 times 2 times 2, which is 8. So you get this answer. This is directly using geometric formula. Okay, if you want to use the triple integral, we have two integrals here. First, you can use triple integral in spherical coordinate to find the volume of the sphere and the cube here. So you deduct volume of sphere, you have to use a triple integral in Cartesian coordinate. So means the volume in this case, volume of a sphere using spherical coordinate, theta 0 to 2 pi, phi 0 to pi, rho is 0 to radius of the sphere, because in this case the sphere is centered at origin, so the rho here, rho squared equal to 9, so rho will be 3. And then dv is rho squared sin phi d rho d phi d theta. Minus the volume of the cube, cube hole of length 2 units. So this is not sphere, you have to use a Cartesian coordinate. So just use 0, 0 to 2 or let's look at the 0 to 2 or negative 1 to 1 through the center of the sphere. The cube here, let's put it symmetric at the origin. So we put at the center of the origin. So the length will be from negative 1 to 1, not 0 to 2. negative 1 to 1. It's not negative 1 to 1, negative 1 to 1. So dz dy dx. Or you change it because all are same limit, or you want dy dz dx, doesn't matter. Okay. So this is a question 3, and then you integrate as usual. So rho squared, you have rho power 3 over 3, 0 to 3, sin phi, this is d phi, theta, okay, this one. Integrate 1 respect to z, we have z from negative 1 to 1, dy dx. So here, 3 cubed divided by 3, you have 9. So this is 9 sin phi dt theta minus, this one you have 2, 1 minus negative 1, 2 dy dx. So now integrate 9 sin phi respect to phi. Factor of 9. Integrate sin is negative cos phi, 0 to 5. So this is theta. So integrate 2 respect to y. You factor of the 2. So integrate 1 respect to y. You have y from negative 1 to 1 dx. So negative cos pi minus cos 0 theta. Okay. So plug in 1 minus negative 1, you have 2. So 2 times 2 total is this minus. So total is 4. Integrate negative 1 to 1 dx. Cos pi is negative 1. Let's look at the graph of cos. Pi here. Cos pi, the value is negative 1. Cos pi is negative 1, so negative 1. Cos 0, this value is 1. Integrate 1 respect to x, you have x. Put in negative 1 to 1. So this was 1 minus 2. Integrate sin negative cos. So negative cos pi, okay, minus, this is plus. Okay. So 1, this is positive 1 plus 1, 2, so 18. Integrate 0 to 2 pi theta. Okay. Plug in the limit for x, we have 2. This one. Integrate, so no more. So that's why, okay, here, the outer integral, you get 2 pi. So 18 times 2 pi, so minus 8. So the answer, okay, is 36 pi minus 8, which is tally as what you obtain using the geometric formula. 36 pi minus 8. Then you can obtain it using formula of a sphere. Then this is a formula of cube, 2 times 2 times 2, you get 8. So this is question 2. So any questions? And number 4 is similar to, I think, last night example. You fill out this one. Similar to this example. Only the radius of sphere is changed. Okay, question 4. Okay, a hole in the shape of cone. This one is drilled out from a sphere x squared plus y squared plus z squared equal to 25. Okay, using spherical coordinate, find the volume of the remaining solid. Okay, this is similar, okay, to what you learned yesterday in this one. Remove the white color, and the cone equation as what you solve in the second equation, right? This one, cone z equal to square root x squared plus y squared. This now we already solve it in second time. This one, you get the phi is pi over 4. For this cone, z equal to square root x squared plus y squared will give you p equal to pi over 4. So we want the from a sphere with radius pi unit. This one sphere. So this if we have rho squared equal to 25. So rho is actually 0 to 5. So in this case, your rho is actually from origin touch the sphere, touch the sphere x squared plus y squared plus z squared equal to 25, or rho equal to 5. So rho from origin here 0 until the surface of sphere, which is 0 to 5. Okay, and we want the remaining solid if this cone is drilled out. Remove the white color. So we left the remaining solid is a gray color, which is start from phi equal to pi over 4. It means the phi is actually you rotate it from here. This one rotate until here. Because phi is actually measured from z vertically. Because this white color is removed, that's why the top surface is from the cone. Phi equal to pi over 4 until the bottom surface at here, which is phi equal to 5. And then how to evaluate it? This is same thing. So the volume, the projection you have here. Full the projection of the remaining solid is they give you the full circle. So theta, this is y x. Because your remaining solid, the projection is actually at xy plane z equal to 0. So your circle is actually x squared plus y squared equal to 25. And it's a full circle. That's why theta from 0 to 2 pi. So theta 0 to 2 pi. Phi from pi over 4 until pi. And rho is 0 to 5. dV is rho squared sin phi d rho dphi d theta. So this is question number 4. I think you can integrate it, right? You have problem to integrate it. Question 5. Question 4. Question 4, is it okay? Similar to last night example. Okay, last night example.
Okay.
Yeah. Example 5, this is 16, but now change to 25 only. Okay. Okay, I leave it to you to integrate it, so you may proceed to the next questions. Okay, the question 5 is a conversion question. Okay, from the Cartesian coordinate, okay, you want to change it to spherical coordinate to evaluate it. Because okay, if you evaluate in the Cartesian coordinate, I think quite difficult. You got all the square root. Normally you need, sometimes you cannot integrate, sometimes it's quite difficult to integrate. So we use a spherical coordinate to evaluate it. So for this type of conversion equation from Cartesian coordinate to integrate it using spherical coordinate, so you have to change it correspondingly. And 3x squared, 3y squared, 3z squared, you can factor out the 3. So 3x squared plus y squared plus z squared, this will become 3 rho squared. And then the dz, dy, dx is actually rho squared sin phi d rho d phi d theta. So totally, okay, this thing you will get that's why totally 3x squared 3 times x squared plus y squared plus z squared dz, dy, dx. So 3 rho squared times rho squared, total you have 3 rho power 4 sin phi d rho d phi d theta. So the integral is changed to 3, total become now 3 rho power 4 sin phi d rho d phi d theta. So we need to know the limit of rho, phi and theta. To get the limit of rho, okay, limit of rho, we look at the okay, this is integral respect to z first. So okay, the first inner integral, this will be z. I mean from here, this one tell you this one is z. So exactly you have square root x squared plus z dz. So this is limit of z. So this is a bottom lower surface is actually z equal to square root x squared plus y squared. So you can, if you're familiar with the equation, so this is a upper cone. Okay, upper cone. Okay, and the top surface is z equals square root 32 minus x squared minus y squared. Minus x squared minus y squared. So okay, we take the uppercase surface here, z equal square root 32 minus x squared minus y squared. Okay, and you square both hand side. So when you square both hand side, you have z squared equal 32 okay, minus x squared minus y squared. So we have x squared plus y squared plus z squared equal 32. x squared plus y squared plus z squared is a rho squared. So rho squared equal to 2. Rho is actually 32. Therefore, rho from 0 up to 32. Okay, and from the lower surface, so it tells you it's actually upper surface is a hemisphere, lower surface is a cone. So basically, you get back ice cream cone here like this. Lower surface is cone, upper surface is hemisphere. So mean this solid is actually, we have the cone. Okay. From lower surface, this is cone. Okay, upper surface, actually you have a hemisphere here. Then what we want is actually only blue color here. From the lower surface, tell you this is a upper cone, upper surface here. This is a sphere with radius 32 units. Okay, after that, and then from the cone equation, as we have solved it so many times from this one, this is actually z equal to x squared plus y squared. If you solve this cone equation, again you get the p is 0 to pi over 4. The cone equation. From z equals square root x squared plus y squared. Okay, square both hand side, plug in the z is rho cos phi, plug in the x rho sin phi cos theta, y is rho sin phi sin theta. Okay, solve it, simplify, you get p is actually from 0, okay, p is pi over 4, whole p is from 0 up to pi over 4. So that's why, okay, from the lower limit of z and upper limit of z, okay, lower limit of z, it tells you p is actually from 0 up to pi over 4. From the upper surface, tell you, okay, the rho is from 0 up to 32. Okay, and later on, to get the limit of theta, okay, we have to look at the limit of y. Okay, limit of y here actually tell you y from negative 16 minus x squared up to positive 16 minus x squared. So mean, okay, the limit of y here tell you this is a lower semicircle curve up to the upper semicircle curve, and x from negative 4 to 4, cone scale this you have is actually the full circle. And for limit of y, the limit of y tell you have negative 16 minus x squared up to positive 16 minus x squared. So limit of y tell you is actually this is negative 4, positive 4. This is a low click from negative 16, negative square root 16 minus x squared, negative 16 minus x squared. So this is actually the lower semicircle. Okay, later on, positive. Negative 4, positive 4. Okay, the black color is actually y equal to 16 minus x squared. This is y equal negative. And then limit of x from negative 4 to 4. So this is a full circle. That's why theta from 0 to 2 pi. Okay, Holmes scale, you convert everything, okay, from here. Okay, theta 0 to 2 pi, phi 0 to pi over 4, rho 0 to sud 32. 3x squared plus 3y squared plus 3z squared dz dy dx. We have solved it at the top part, which is 3 rho power 4. 3 rho power 4 sin phi d rho dt d theta. 3 rho power 4 sin phi d rho dt d theta. And then later on, I think the similar integral only. So do you have any question on this question? Question 5 here. Conversion questions. We convert one by one. 3x squared plus 3y squared plus 3z squared is 3 rho squared. dz dy dx is rho squared sin phi d rho dp d theta. So total is 3 rho power 4 sin phi d rho dp d theta. So we could change it here. You need to determine the limit of rho phi theta. From limit of z, okay, this one tell you this is z equal sud x squared plus y squared, which is cone, upper cone. Z equal sud x squared plus y squared. This is upper cone. Solving this upper cone, you will get phi is actually pi over 4. Okay, and then from the upper limit of z, this is actually upper hemisphere. Z equals sud 32 minus x squared minus y squared. If you square both hand side, you get the limit of the rho, which is sud 32. And then from limit of y and limit of x, it tell you this is actually, limit of y tell you this is actually from lower semicircle up to the upper semicircle, and limit of x confirm that x negative 4 to positive 4, so your circle is full circle. Because from the red color up to the blue color, and x from negative 4 to 4, so the circle is full. Because if x from 0 to 4, and then your circle is only the from in the first quadrant and the fourth quadrant. Then the theta you can have, let's say 3 pi over 2 to pi, or negative pi over 2 to pi, and negative pi over 2 to positive pi over 2. Then put up your limit of rho phi theta. So later on you just integrate it as usual. So I think once you get the limit correctly, you can integrate it right. Because this one you don't have a difficult integral. So any question for question 5 here? I hope you can continue to do it. Maybe give you some time to do complete it. Whether you can get this answer. If you cannot get like this one, you just convert to floating point. So is it okay? Question 5 here?
Okay. Okay.
Six, 7, 8, 9, 10, all are same time. The 6 also same type. Okay, Number 6 also same type because the bottom here z equal third x squared plus y squared. This is a upper cone. This is an upper hemisphere. So from this one, we will from the lower lower limit of z will tell you the t is pi over 4. This one will tell you your rho is actually 2. Rho is 2. Only the difference here. Limit of this one is integrate respect to x first. X is from negative 2 minus y squared. It's actually the left curve up to the right curve. In the circle, if you cut it at x-axis, you have a lower curve, upper curve. If you cut it at the y-axis, you have the left, right curve. Look at the question 6. I think I will just guide you to get the limit and then you will proceed how to integrate it. So this one same thing, x squared plus y squared plus z squared. So this one first. X squared plus y squared plus z squared power 3 over 2 and then dz, dx, dy. This is a x squared plus y squared plus z squared is rho squared and then power 3 over 2. dz, dx, dy is a rho squared sin phi d rho d phi d theta. So you got rho cubed times rho squared. So total rho power 5 sin phi d rho d phi d theta. Okay, and then from limit of this one dz first, so this is limit of z. From square root x squared plus y squared up to 4 minus x squared minus y squared. Okay, from z equal square root 4 minus x squared minus y squared. You square both hand side, you will get x squared plus y squared plus z squared equal 4. So you have the rho squared is 4. So rho is 2. Okay, rho is like the radius of a rho is radius of sphere, r is radius of circle, is always positive number. Minimum is 0. So don't take negative. Then from this equation, this one tell you z equal third x squared plus y squared. Solve it, you will get phi equal to pi over 4. So you have the limit of rho and limit of phi. Now, from the limit of x, limit of x is actually from negative 2 minus y squared. This is x, because dx is a middle. So 2 minus y squared. Okay. The circle is actually, this is y, this is x. the blue color is actually y. In the circle, if you cut it at the y-axis, you have here x equal negative z2 minus y squared. Because left side is x negative. This is bottom negative 2. In the circle, okay, with radius 2 units centered at origin, okay, when you cut it off here, when you square back, x equal positive negative 2 minus y squared. Okay, when you square it, this is actually x squared plus y squared equal to 2. Okay, so my intersect, this is wrong, this is Z2. Negative Z2, negative Z2, Z2. So the blue color is actually x, the blue color curve, or what we call left curve, is x equal negative Z2 minus y squared. Okay, the right color curve, so this is positive Z2. The black color is x equal positive Z2 minus y squared. So from limit of x tell you have the left curve, right curve, okay, or the left semicircle, right semicircle. Okay, however, limit of y tell you y from 0 up to Z2. So y is, okay, from here, y 0 up to Z2. So therefore, we'll get, okay, y0. y0 is on x-axis up to y equal to Z2. Okay, therefore, the pi is actually, because you have pi rotate from x positive until here. So theta, okay, is half, okay, cycle. So theta is 0 to pi. In this case, theta 0 to pi. So, okay, any questions here? I think the limit from the lower limit of z tell you phi similar to equations pi. From the upper limit of z give you the limit of rho. From limit of x tell you have the blue curve, which is a left circle or the right semicircle. And then x equals Z2 minus y squared. The blue, the black color is the right semicircle. However, y from 0, y0. X-axis is actually y equal to 0 until y equal to Z2. That's why it's only semicircle. Theta from 0 up to pi. Okay, so up to here, any questions or not? If no, you just keep putting correspondingly and then integrate it. So mean that's why the theta 0 to pi only. Phi 0 to pi over 4. Rho 0 to 2. Okay, and then the integrand and dz dx dy. Total you have rho power pi sin phi d rho d phi d theta. Total you have here rho power pi sin phi d rho d phi d theta. So this is question 6. So the main thing, to get the limit of rho, phi, and theta correctly. Later on, I think you should have no problem to integrate it. Even though you have problem, you can use the software or the calculator to help you. So question 6 here. Any questions? Question number 6. Any problem or not?
No.
So you continue to integrate. I just give you the hints to get the limit. Okay, number 7. Use spherical coordinate to evaluate. Same thing. 6 and 7. Integrand chain. Limit of z same. This one, the only difference, the integrand here differ. Limit of z, you see, here same with question 6. Okay, and then now dx is from 0 to sec 2 minus y squared. So mean, okay, here, compared to question 6, now x from 0 is on the y-axis until x equal, this will be x equals sec 2 minus y squared. So mean you have only right semicircle. So this is negative sec 2. This is positive sec 2. Okay, and the outer integral dy, y from negative sec 2 up to 0. Okay. So it's only the fourth quadrant. The fourth quadrant. So theta is from not 0. The third, so here is 3 pi over 2 up to 2 pi. So theta in this case is from 3 pi over 2 up to 2 pi. The limit of x 0, x0 on y-axis, okay, up to this is x equals sec 2 minus y squared, right semicircle curve. Limit of y from negative sec 2 up to 0. So it's only the third quadrant. So the theta, you rotate from here to here is, this is 3 pi over 2 up to cos. Okay. If you start from here, first quadrant, then you have 0 to pi over 2, but it's only from at the fourth quadrant. So 3 pi over 2 up to theta equal to 2 pi. Okay, and then with the same thing here, from limit of z similar to question 6, okay, from z equal sec x squared plus y squared, you square both hand sides, simplify, you get p is actually pi over 4. Okay, from the upper limit of z here, this is z, okay, z equal sec 4 minus x squared minus y squared, similar to question 6, you square both hand side, x squared plus y squared plus z squared equal 4. So rho squared equal 4, rho equal 2. So you have limit of rho 0 to 2, limit of p 0 to pi over 4, limit of theta in this case is 3 pi over 2 up to 2 pi. And then you need to convert square root x squared plus y squared plus z squared dz dx dy in spherical coordinate. So you have square root x squared plus y squared plus z squared dz dy dx. So x squared plus y squared plus z squared is actually the rho squared. Dz dy dx is rho squared sin phi d rho d phi d theta. So square root rho squared, you have rho, so rho times rho, okay, squared total is rho cube sin phi d rho d phi d theta. So question 7. Where the theta is 3 pi over 2 until 2 pi. Phi 0 to pi over 4. Rho 0 to 2. And then the integrand combined with dz dx dy, in total you get rho cube sin phi d rho d phi theta. So again, I think a similar technique, okay, because you have not don't have a difficult integral to integrate, you should have no problem to integrate it. So as long as you get the limit correctly, you should be able to integrate it. So this is question 7. So do you have anything to ask about question 7 here? I just show you up to the limit. Later on, okay, you have to do, okay, to integrate by yourself. So question 7, any problem? Question 7, anyone want to ask?
Got it. Yeah.
No, question 8, I think also similar. Can you see? Okay, dz. This is okay, question 7, a slightly different cone equation. So the phi is not pi over 4. We have to solve this cone equation. Okay, and this one is a mass of a cone. It is, okay, you have the bounded lower, okay, surface is a cone, upper surface is actually the upper hemisphere or, okay, or the sphere. And then what? Okay, remember we learned volume is triple integral dV. Okay, and you have the mass, okay, that you learn in physics is your density. So the rho. So in physics you will learn the mass is a density rho divided by volume. So the density is actually mass by volume. Okay, since we use a rho in the spherical coordinate as a radius of the sphere, so the density in here we use a delta. But our density function is okay, it's not constant value as what you learn in physics. It's not. Then you have a rho. Formula. The density is a mass divided by the volume. So the mass is a density times the volume. Okay, density that you learn in physics is constant, but now, okay, here we have the variable density function. Okay, that's why we have, okay, put into the triple integral where the mass, okay, because this is not constant value, so we have some sort like mass is density times volume, but density is not constant. It's a function, okay, of x, y, z here. That's why we put it into delta x, y, z, dv. So it's some sort like it. Density times the volume, you get the mass. But because density is not constant, you cannot simply factor out. That's why it's because your density is function of x, y, z. You have to integrate it inside the triple integral. So that's why mass is given by here. The density function x squared plus y squared plus z squared. dv is a dz, dx, dy. And again, this is in the Cartesian coordinate. Convert it using spherical coordinate. So the shapes is here. Bottom is cone. Top is upper hemisphere. But it's not the full ice cream cone. Because limit of x 0 to third 3 minus y squared. Limit of y 0 to third 3. So from limit of x and y, the projection is only quadrant of circle. Quadrant of circle. Look at here, dx. This is x equals third 3 minus y squared. From limit of x from 0 is on y-axis until x equals third 3 minus y squared. So this is a right semicircle, right hand side semicircle. Limit of y tell you y equal to 0, which is on x-axis, y equals 0 until y equals third 3. This is negative third 3. This part is third 3. So it's only first quadrant. That's why the solid is actually not the full ice cream cone. In the ice cream cone, you cut it into four parts. You cut symmetric. Cut it. It's only this portion. It's only this portion. Because this is a portion x positive, y positive. So it's only 1/4 of this ice cream cone. If the ice cream cone is symmetric and you cut it, take out 1/4 part where the part is x positive, y positive, also z positive. And then we are going to convert it using the spherical coordinate. So here I hope you can jot down. Volume is triple integral dv. Mass of solid. This is actually mass of solid. Mass of solid is given by triple integral density function dv over the solid G. This is question 8. Question 8. Okay. Just now, since here, from limit of x and y tell you the projection is on first quadrant. That's why theta 0 to pi over 2. Means in a theta 0 to pi over 2. Okay, to get the phi for that here, x squared plus y squared plus z squared dz dx dy. X squared plus y squared plus z squared is a rho squared. Dz dx dy is rho squared sin phi d rho d phi d theta. So total is rho power 4 sin phi d rho d phi d theta. Okay, and from lower limit here, lower limit of z, this one, is z actually from 3 x squared plus y squared. Okay, this is z. Up to z equal 12 minus x squared minus y squared. Okay, from upper space or the upper hemisphere here, z equal, from this one, z equal 12 minus x squared minus y squared. Square both hand side, you get x squared plus y squared plus z squared equal 12. So you have rho squared is 12, so rho is 12. So rho, okay, is actually from 0 up to 12. Okay, and from here, from this one, z equals third from here. Lower limit of z. Z equals 3 x squared plus y squared. Okay, again, square both hand side. Eliminate the square root, you square both hand side. Okay, now plug in z is actually rho cos t. So z squared. So rho squared cos squared t. Okay, x is actually rho sin phi cos theta. X is rho sin phi cos theta. Squared it. Sin squared to cos squared. Okay, y is rho sin phi sin theta. And then y squared. So rho squared sin squared phi cos squared theta. So you have here the common term rho squared sin squared phi factor out. So total you have 3 rho squared sin squared phi and cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta is 1. So you get this is 3 rho squared sin squared phi. So this is rho squared cos squared phi. Okay. Cancel rho squared at both hand side. So you have actually 1 divided 3 equal to your sin squared phi divided cos squared phi. Okay, if the coefficient for the cone, okay, if the coefficient for the cone here, this is 1, when you solve here, you get the phi is pi over 4 because you get here is 1. So now you have a tangent squared phi is 1 over 3. So tan, okay, and okay, taking the square root, you have 1 divided by 3. So the phi. You make it, find the phi here. Sin pi sin 30 degree, which is sin pi over 6. Sin 30 degree is actually half. So this is pi over 6. Sin, okay, pi over 6. You have the over 6, okay, over 6 length is 1, hypotenuse is 2. Then you can solve the adjacent length here using Pythagoras theorem is to be 3. Okay. So pi over 6. That's why p is actually pi over 6. Because tangent, okay, tangent p 1 over 3. So p is pi over 6. So phi in this case is from 0 to pi over 6. Okay, or you may use your calculator. Just make sure in radian, arctangle 1/3. pi/6. You get pi/6. So now you have the limit for your phi is from 0 up to pi/6. That's why I said the phi depends on the cone equation. If this cone equation z equals 3 times x squared plus y squared, phi, solving the cone equation, we get phi is pi/4. If z equals square root, this is 1, x squared plus y squared, solving, again you get phi is pi/4. Okay, so now this one we already have the rho phi theta. If put in, then you can integrate it. So we have phi theta. Okay, theta 0 to pi/2 just now. Theta 0 to pi/2. Phi from 0 to pi/6. Rho 0 to 12. Rho solving the upper hemisphere equation. Phi solving the cone equation. And then theta you have to determine from limit of x and limit of y. So x squared plus y squared plus z squared is a rho squared. So and then times dz dx dy. Now this one is rho squared. This is a rho total rho power 4. This is rho squared sin phi d rho d phi d theta. So total is rho power 4 sin phi d rho d phi d theta. So in this case, you can continue integrate it. After convert one by one, goes x squared plus y squared plus z squared, you get rho squared dz dx dy is rho squared sin phi d rho d phi d theta. So total is rho power 4 sin phi d rho d phi d theta. Solving the upper hemisphere equation here. Z equals 12 minus x squared minus y squared from hand side. Okay, you get rho is 2. Solving the cone equation, you get the phi is actually pi/6. Now you can integrate it. Start from rho. When you integrate respect to rho, phi is constant, theta is constant. Then plug in the limit. Later on, integrate respect to phi. Integrate sin phi, you have negative cos phi. Plug in phi from 0 to pi/6. Lastly, integrate respect to theta from 0 to pi/2. So this is about the questions. Question 8. I hope you can continue. Integrate it because answer is given here. If all are given into in like fraction point, in fraction form, you can convert to floating point. So 9, also similar pattern. When you see, if you do a lot, you can see question 9. This code equation tell you phi is pi/4. Upper limit of z tell you the rho is 18. And then limit of x and y, you can tell you theta is from 0 to pi/2. First problem. Okay, if you do it several times, you make sure you understand the equation and know to sketch the graph, the curve, then you can know the theta there. Question 9, 10 also similar, 11. Oh, I think similar. Only 13, I think a bit different. 13, this is a cone and then a flat surface. Similar to the last example, okay, what we said, the last example in yesterday, okay, last night lecture. Okay. So this case, have any question? Are you all around or not? Or just open there, but
No.
no. Okay, if not, okay, we are going to end the class. Okay, hope you can continue. Okay, evaluate it.
Okay.